Okay, here we go with part 2 from the Impulse lesson, and what we're going to do this time is take a look at graphically representing impulse by graphs. So remember, J is F times T, also change in MV. If we look at this right here, we can make a graph of force and time, and then we'll see what this really means. If I've got time, I've got force on this axis, force times time. Now let's go back to the example of the throwing the baseball from before, from the last video. We had a 1 kilogram baseball. We had a force of 200 newtons and a time of 0.1 seconds. So if we want to graph that over on our graph over here, let's just say there's 0.1 and there's 200 over there. So here's the force. Over time, the force is just doing this, staying up there, just like that. So we can see that force times time is actually just the area underneath here. So that's the area. So the impulse is the area under the graph. So that should immediately make you think of calculus. Now what we can actually write this as is J is the integral of force times dt. Now, if you have a constant force like this, you don't really need to integrate. It's just a rectangle. If you have another situation where you have, say, an increasing force over time, but it's constantly increasing force time, let's say your force is doing this over time, it's constantly increasing like that. Same thing, you can just find the area underneath here, and you don't really need calculus for it. Where you need calculus is if you have a graph where force is doing something funny, like that, force and time, and then you'd need some sort of calculus to do this. You'd have to know what the equation is for this graph. You'd have to have an f of t equals something, something, something. So let's do a quick example like that, where you have a force that's not constant, it's a varying force. All right, so let's see. Just making something up, let's say I've got an equation that looks like this. Force as a function of time is 3t squared plus 6t. And I want to say that the force acts from t equals 0 to t equals 2 seconds. So you need some limits if you're going to integrate, right? And the question is, what's the impulse? All right, pretty easy to do. Impulse is integral of f times dt. So here we go. We're going to integrate. Our limits are going to be 0 to 2, and we're going to take 3t squared plus 6t dt. Yep, that's just going to get us, let's see, that's t cubed plus t squared, 3t squared, and we're going to evaluate that from 0 to 2. So that's going to get us 8 plus 12 minus 0. That gives us 20. Right, so that's the impulse right there. That's the change in momentum. So all we had to do is know what the equation of the graph was like, and then we could figure it out from there. Let's do one more impulse problem just to sort of see how this is all going to work out. Just a simple impulse problem, because you'll have some problems like this, some homework problems. Let's see. It's not going to work underneath there. All right, so how should we do this? Let's say that we've got a car. Just making up a problem. And it's driving down the road at 20 meters per second. And the pick and mass of the car is 500 kilograms. And then it's going to hit the brakes, and it's going to slow down and stop after 8 seconds. I want to know how much force is necessary to have it slow down and stop after 8 seconds. Once again, we can do F equals ma and have it work out this way, but just for fun, let's just use impulse. J is F times t, that's change in mv. So I'm looking for the force, I know the time, I know the mass, and I know the change in velocity. Mass times change in velocity. Right? Let's see. Force is what I'm looking for, times the time, 8 seconds, is over here mass, 500 kilograms, times the change of velocity is 20 meters per second. I guess technically the change in velocity should be negative 20 meters per second, since it started at positive 20 and it ended up at 0. Right? So it stopped at 0. Right? Then that's pretty easy to do. So you guys even see that? Yeah, I guess so. Alright, so we take 500 times 20 divided by 8, and that's 1250. 1250 newtons. Right. These problems aren't really so hard. Just remember to set them up like this. Force times time is change in momentum. You'll know some of the pieces and you won't know some of the pieces. Sometimes it takes a couple steps to get where you need to get to, but in general you should be able to do them. So now you should be able to do all the problems from chapter 9.